So here's a density worksheet I've given you. Very often there's a question about number 1. It kind of throws people for a loop, basically because it's simple. People are trying to make it harder than it really needs to be. But for number 1, I want you to think about water displacement. So what is the volume of an object that causes the water in a graduated cylinder to rise 25.8 milliliters? So visualize there's a graduated cylinder with water already in it, and when I place that object in the graduated cylinder, the water goes up 25.8 milliliters from where it started from. That will tell you what the volume is for that problem. For number 2, you need to find the density of that object. Now the object they're referring to is the object in question number 1. The mass of that object is 21 grams. Use that mass, that volume, and you can plug it into this equation to figure out what the density would be. Now when you're plugging these numbers into the equation, make sure that your units are following. So the mass is 21 grams. Make sure you don't put a 21 in the numerator, put a 21g in your numerator. A lot of times students will find a density that's a number and they'll not either put a unit on there at all, or they will want to know what the unit needs to be. If you put your units in the problem will tell you what the units for your answer should be. For number 3, use the density you found in number 2 to determine whether that object is going to float or sink if you place it in a container of water. So questions 1, 2, and 3 are all linked together. Questions 4, 5, and 6 are also linked together. So in question number 4, we have a new object. This rock is placed in 100 milliliters of water, so we're using water displacement. And that 100 milliliters of water goes up to 134 milliliters. That information there should tell you the volume of the rock. Using that volume and this mass here, use the D equals m over v equation to calculate density to answer number 5. Number 6 a little bit different. Number 6, again, you're taking that same rock that you had in 4 and 5 and you're cutting it in half. So if you cut that rock in half, what is the mass of each piece? What is the volume of each piece? And given that mass and given that volume, what is the density of each piece? So 4, 5, and 6 also go together. Number 7 is its own problem, and number 8 is its own problem. So for number 7, it's a little bit different in the fact that the density is given to you. The mass is given to you. So you are looking for the volume. So it requires a little bit of algebra there. And if you don't like the algebraic way, density is mass over volume. We're looking for volume. That's our unknown, which means we need to get V by itself. V is being divided here, so why don't we multiply both sides by V? V on the numerator, V in the denominator will cancel out. V is not by itself though. It's V times D equals M, so I want to get rid of D. Since I'm multiplying it here, the mathematical opposite is to divide, so I want to divide both sides by D. D cancels in order to clean this up a little bit. V is by itself on one side. It equals mass divided by density. That would be the equation for V. There's also the magic triangle method. May have used this before. D equals M over V. And since I'm looking for volume, I want to cover up my V. When I cover up my V, the equation becomes M divided by D, just like I have over here. For question number 8, again, they give me the density. They give me the volume this time. Now I need to know the mass. So you can do it the algebraic way. Density is mass over volume. I want to find the mass, so I need to get M by itself. I'm dividing by V, so I need to do the mathematical opposite, which is multiply by V. V on the top and bottom will cancel. M equals D times V. Or I can go to the magic triangle again. Since I'm looking for mass, I cover up the M. D times v. They're on the same level, so I'm multiply across. I'm not dividing.